Welcome to Lesson 35, finding arc lengths in areas of sectors. In today's lesson, we are going to use the formula for the area of a circle and the circumference of a circle to figure out whether your brother cheated you out of pi. Not even kidding. The objective is find arc lengths in areas of sectors using proportionality logic. So back to your brother. Your brother cuts you a slice of pie. How could you tell how much of the pie you got? Let's say you didn't even see the full pie. You didn't walk to the counter and compare it to the full pie. Let's just say you got your piece. And you could tell he cut it from the center because there's a little divot from the middle. So you know your two slices are very likely radii if you started from the center. So how could you tell how much pie you got? Well, you may think you're at a disadvantage because if you're looking at the pie as a whole, and maybe this is the missing piece, you can tell it's maybe about 1/6 or 1/7 or 1/8. Or if you saw dividing lines, you might say that's 1/6 if that's the way it was cut. What if you only had the piece of pie? Is there an angle you could measure? Would you use a tape measure? What do you think? What would be the easiest way to figure out if you just had the slice of pie? To figure out what percentage of the pie or what fraction of the pie you got. Well, if you knew the formula for the area of a sector, you'd be in good shape. What if your piece of pie had an angle, a central angle of 50 degrees? Well, if you consider the full pie, all the pieces added together, their central angles would all add up to 360 degrees. So if you only got 50%, or not 50%, 50 degrees of that 360 degrees, you got 5/36 of the pie, or approximately, that's pretty close to 1/7 of the pie. Now, depending on the number of people in your family, you might find that fair. You might be a little suspicious your brother is somewhere eating 6/7 of the pie. How dare he? Mom! Danny's eating all the pie again. Might be necessary, if that's something your brother would do. So the area of a sector, this is essentially saying what fraction of the circle are you looking at? So you take the fraction of the circle that you have times the area formula. That's essentially what the formula for the area of a circle, or for the area of a sector is. It's just your regular circle area formula times what fraction of the circle it is. So if you're looking at a 90-degree sector, you would take pi r squared times 1/4, for example. So let's say that these are the dimensions of your pie slice. The radii on both sides of your pie slice are 4 inches, not counting the crust, because who eats that anyways? So if your radii are 4, and your central angle is 50, you'd do something like this. So you'd say pi times 4 squared, which would be 16, times 50 over 360. Okay, which reduces to 5/36. And we could cancel the 16 and the 36. Let's see what would be the biggest number that would go into both of them would be, let's just do 2, 18, and 8, no, 4. So I can divide this again, 9 and 4. So, if I do 4 times 5 times pi divided by 9, that would be 20 pi divided by 9. That would be the area of the sector. So we could try that with a calculator. So 20 times 3.14 divided by 9 is 6.97 repeating, which means you got approximately 7 square inches of pi, which means if there's 6 other approximate pieces like this, it means it's roughly a 49 square inch pie. And you only got about 1/7 of it. Hopefully your mom stops your brother before he eats the other 6/7. Otherwise you're going to have one angry family. Arc length. Before we talked about arc measures, the difference between a measure and a length. The arc measure, this arc measure is, let me use a different color, is 50. So that's the measure. The length is more akin to the circumference. The length is just the portion of the circumference. Or if you took a tape measure and wrapped it around that part of the arc, what would the length be? Okay. Using the same logic as our area, if we do 2 pi r times the sector that this arc length comes from, and again we have 50 over 360, which we've done once or twice already, reduce this to 5/36. So, let's do this. So the 2 pi r would be 2 times pi times 4, which would give us 8 pi times 5/36. And 4 goes into both of these, so 2 and 9. So we would have 10 pi divided by 9. So if we wanted to go a step further, we could do that on the calculator, but we'll leave it in terms of pi. I think you get the idea. So if you want the arc area, the arc sector area, you take the pi r squared and you multiply it by the sector of 360. So if it's 90 degrees, it'll be 90 over 360, which will reduce to 1/4. And if you want the arc length, you just do the 2 pi r, which you would normally do for circumference, and multiply that by what fraction of 360 the slice is. So if you already know the area formula for a circle and the length, the circumference formula for a circle, the only added caveat here is you just gotta figure out what fraction of 360 that slice is, and you can multiply that by the corresponding area formula or circumference area, and you're good to go. But like I said earlier, when you're asked for the length, that's in like inches or some other unit. When you're asked for the measure, the arc measure, well, that's equal to the central angle. That's going to be in degrees. So that's maybe the one other thing to learn from this lesson. Remember the difference between measure and length. Measure is in degrees when we're talking about arcs. Length is in inches or feet or yards or whatever unit is being used in the problem. Well, we will see you in lesson 36. Don't let your brother eat all the pie. That's the other thing to take away from this lesson.